A new day has dawned in the North Sea. Alpha Ventus is Germany's first offshore wind park, 60 kilometers off the coast, where the winds are strong and enduring. Installing and maintaining facilities this far out to sea is a great human and technological challenge. But Alpha Ventus won't be alone for long. In the coming years, more than 30 offshore parks will spring up in the North Sea and Baltic. By 2030, the parks are expected to produce electricity equivalent to the capacity of 60 nuclear power plants. But what happens when the wind dies down? And how does the electricity get from the high seas to the consumer? Offshore plants produce alternating current, just like traditional power plants on land. That means the voltage changes 100 times per second, also changing the direction of the current. The problem is that unlike high-voltage power lines on land, the sea cable's conductors are very close to each other. As a result of physical effects, the currents continuously charge and discharge the isolator like a battery. The same thing happens in the sea cable that's supposed to transport electricity to the shore. The longer the cable, the more electricity is needed for the continuous charging and discharging of the isolator. For lengths of more than about 70 kilometers, the charging current blocks up the sea cable, and no more wind power can be transported to land. To solve this problem, scientists and engineers at a Munich semiconductor company are testing electronic components in a special laboratory. The components have to intelligently manage large quantities of electricity under offshore conditions. To get the electricity flowing from the wind power plant to the shore, electronic engineers have developed robust power switches suitable for the high seas. These computer-controlled units can switch very strong currents on and off. For one test, the switches are built into a power converter. Thanks to the converter, alternating current that continuously changes direction is transformed into direct current that only flows one way. The test shows that direct current is the solution to the problem. Now, no more energy is needed for the continuous charging and discharging of the isolator. The cable is no longer blocked, and the wind-generated electricity can now travel over long distances to reach land.
You need approximately 100 of these units to bring electricity from one of these big wind parks to land. These units, the converters, are located on large platforms in the North Sea or the Baltic.
Following the lab tests, the engineers look for a suitable location for the platform in the North Sea. Together with geologists, they board a research ship. Since around 100 converters will be installed on one platform, the entire station will weigh several thousand tons. That requires a firm and flat seabed. With the help of sonar equipment, the scientists scan the depths. Not far from a planned wind park, they find a suitable location. An electronic high-tech facility is taking shape in the middle of the sea, far away from the coast. The converters transform the renewable alternating current produced here into direct current that's transported through the sea cable to land with almost no loss. But this technology can do more than make offshore wind energy available to consumers. Electronic engineers envision technology connecting several wind parks with bordering countries in a single network. If strong winds in the North Sea and Baltic produce more electricity than needed, the excess wind power can flow through the new network to Norway, a country that possesses enormous water reservoirs. The excess energy powers numerous pumps that boost water up a mountain. And when the sea wind dies down again, the water flows back into the valley. Generators then produce power that's fed into the grid. So-called pump storage power plants are able to store wind energy for days or even weeks on end.
This technology enables us to store the energy from several wind parks just like in a battery. The biggest battery in Europe can be found in Norway. That's where we can collect huge amounts of water-powered energy and make it available to consumers in Central Europe on short notice.
Thanks to the seaworthy converter, it's now possible to connect offshore parks to the land and to Norwegian reservoirs. This makes renewable energy from the North Sea and Baltic available to consumers no matter how strong the wind is blowing. And that could put wind in the sails of offshore park construction.